French. But not so far away. Association was not so strong, so we had to reconfigure the team. So Safran said, okay, I want to continue, but not myself because it's really a product not growing in my core business. I will delegate this to a subsidiary, which is called ASC. And Zodiac was keen to continue with funding, so we are continuing with internal resources on specialist. So this has somewhat absolutely caused a perturbation because the outcome of what was done in the first year was not exactly the one that we were expecting. So this has brought delays, but now we are content with people which are more focused here. Before, there was not full agreement on the objective. Now that we have newcomers that we are paying, that's another thing. So if you pay, you get what you want. Okay, we have to take that same device, but we have a team which is much more assistance. So you will see something.
Very good. I was really curious.
So now the new programs are really keen on achieving this target. So I think we will be able to show you something interesting.
Good morning, everyone. Welcome back for the second day of the conference. We will start this morning with a new panel, which will discuss and maybe try to answer the question, is General Aviation an incubator for new technologies? The panel will be moderated by my colleague Stefan Ronig, Stefan is drones and light aircraft manager at EASA. Stefan, the floor is yours. Thank you.
Yeah, thank you, Dominic, for the introduction, and thanks everybody to join us in this early session today. It seems GA has a lot of interest for a lot of people, and I think we have an interesting topic, and we will see quite some interesting presentations and discussions. So the topic today is a question. It's is general aviation the incubator for new technologies? And for me, it was not really a question. It's aviation started with what we call today general aviation. So for the past, I have really no doubt that this is an incubator. But on the other hand, looking on the title, I of course used Google, and what is really an incubator? What comes out of an incubator? And it can be a lot. It can be something that is able to walk alone, or it's something that might need some help or even cannot survive. So maybe some examples where I'm very convinced that new technologies have been introduced in GA, and you see here composite technology in the pictures, the aircraft on the top, the pictures where it shows where some of the panel members had some personal involvement. It's the first aircraft completely built out of carbon fibers, and this was nearly 40 years ago, and it was already the third generation of composite aircraft that was developed. So it's an old technology developed in GA, and of course there are a lot of other new technologies visible on the, or not visible on the pictures, variable wing geometry, laminar airfoils, rescue systems for the aircraft, new materials, HM fibers, but not all of them are really successful or lead to a commercial successful product. The second aircraft you find in a museum. It does not mean that it's not a success, that the project was not a huge success, but not every attempt automatically leads to a successful product. So for me, the question can be developed in two ways. For the past, for me the answer is clearly yes. For the future, it's okay. It depends. Is it what comes out? Is it a ready to use technology that can be introduced everywhere? Is it something where we have to learn? Is it something that we have to support? So, and hopefully we will see some examples for new technologies here and have a discussion on that. This is an example. Unfortunately, the company could not attend here, of a project that is coming to EASA, and you see a lot of technologies here. It's electrical driven, it has a lot of engines, so it's not a question of single engine or twin engine, it's between 20 and 30 engines, electrical fans, vertical takeoff, a lot of autonomy. You see in the picture that they intend to operate in cities. We will see how this develops. It's challenging, and I already had a lot of interesting discussions on the last day here. I was approached by several people with huge ideas, and they are realistic. They are real ideas, they are real projects behind. So let's see what we have here. We have 3 presentations from industry. The first one, I'm very pleased to have a company here that's from Slovakia, AeroMobil, and Hugues will present the project.
Good morning, ladies and gentlemen. I'm Hugues Le Cardinal. I'm the head of airworthiness of AeroMobil. AeroMobil 4.0 is a flying car designed here in Bratislava. We will start with a video to present our product. The vehicle that you've seen on this video is model 3.0 that has flown in 2014, and the pilot on board is Stefan Klein, one of the creators of AeroMobil with Jura Vakulic. Then technology means complexity and request time. As you can see on this slide, the AeroMobil has a lot of innovation. It started with a dream from Stefan. Then from a dream it became a prototype, and in reality a few prototypes. All those prototypes have flown, the first one in 1990. And then they built a new one, and in 2010 they decided to create a company, and from a dream, from a prototype, they decided to prepare a product to be on the market. Then it's a very important date for AeroMobil, 2010, the creation of the company. Then they design some new prototypes, and what would be the future? The future is that AeroMobil is designing a new version, of course, an improved version of its vehicle. Next year, we will apply for the EASA type certification. Next year, we will have a new prototype in flight, and we intend to obtain the EASA type certificate in 2019. What are this project is a challenge. What are the main challenges for AeroMobil? First, we need to obtain an homologation as a car and a type certification as an aeroplane. It means two sets of regulations, perhaps some inconsistencies. Oh, sorry. And but in some case, perhaps some good ideas from one side or the other. We also need to have a propulsion for the road and a propulsion for the flight. This is not easy. The controls is a big issue because the driver and the pilot remain on the same seat in our design. Then in front of the same seat, you must have the classical car control that you all have in your cars. And you also need to find the classical aeroplane controls that you find in the aeroplanes. And this is a big challenge. Aerodynamics is complicated because of car regulation. The aeroplane is, the length of the aeroplane is limited. And all the aerodynamics specialists in the room will understand the difficulty to design what I could say a short aeroplane. Then a big challenge on aerodynamics. Simon and his team perform a very important work on that. And last but not least, weight and center of gravity. On a car, you've got four big wheels. You've got very nice brakes, but this is weight, and this weight is not useful for the aeroplane. And the center of gravity is also a big challenge. This is design and also certification, because we will need to make some proposal for the site certification. The AeroMobil 4.0 is a European light aircraft of category 1. Which in the EASA procedure should allow some alleviation in the procedure. We will use the future CS23. The NPA has been published this year, and the new rule should be published by EASA prior to the end of the year. That's the schedule. We will use this rule, and then we will be one of the first projects that switch from the, let's say, old prescriptive rules to the new rules based on safety objectives. This is very important for us because with this new rule we have the possibility to propose some means of compliance to the EASA, and EASA has to accept. EASA remains the boss. For example, for the occupant protections or for the fuel tank the automotive requirements are more severe than the aeronautical one, then we will propose to EASA to use those automotive requirements for those two subjects. And using those automotive requirements for the aeroplane certification, we should meet the EASA safety objective defined in CS23 Amendment 5. This new rule will also allow us to propose some new means of compliance in other fields as stolen spins. In the new rule, you are concentrated on the safety objective, and the main case you have to study is the stall during the last turn. We will concentrate on that. Then this new rule will allow us to propose some means of compliance. The objective of an aircraft manufacturer is to design a good product. What is a good product? It's a product that the customer likes, and it's a product that is safe. It's obvious an aeronautical manufacturer will not produce something that he doesn't think it's safe. And for us, minimizing the certification costs does not mean at all minimizing the safety level. But we have two kinds of tests. We perform a lot of tests during development that are not part of the type certification in order to have a good and safe product. And those tests, we perform them as we want. When we perform a test during type certification, you need to have the test program approved. Sometimes you need to have the witnessing of the authority. Then just be convinced that for us, minimizing the certification efforts does not mean reducing the safety. Thank you for your attention.
Yeah, thank you very much. We intend to go through all the presentation and then come to the question. I see the first questions arrive in Slido. So, but let's continue and then we open the floor.
Okay, thank you. Good morning. My name is Martin Volk. I'm responsible for Diamond. Thank you. This was one too much. Yes. Yeah, I'm responsible for Diamond Aircraft's design department. Diamond Aircraft, I want to say a few words to Diamond Aircraft. We are a not anymore small, but not yet big company. Quite close to here. We are 100 kilometers southwest from here. And we produce small composite airplanes. This is the purpose. We have about 450 people working there. And yes, right at the beginning, I really like to answer the question, is General Aviation an incubator for technology with a yes? Stefan already mentioned the composite technology, and this is only one topic. One reason why there are so many possibilities in general aviation, we saw this really impressive program, AeroMobil, is maybe there are private owners, and those private owners if they have a vision and are convinced, they just do it. It's their investment, it's their money, their risk, and this gives a lot of opportunities. Yeah? On the first page, there is a car. Yes, it's a car again. We in small airplanes, there is no doubt that the automotive industry is the pacemaker in technology for us. Our customers, our airplanes are more expensive than cars, and our customers require automotive standards in their airplanes. Most of our airplanes in Diamond Aircraft are powered with automotive diesel engines. We converted these engines to aviation engines. Very important is that they burn kerosene. We don't use automotive diesel, we use kerosene. And this is just a key selling factor, because all the new markets, they never ever will establish an infrastructure for aviation gasoline, for this leaded stuff, yes? Not green at all. But it's just an economic factor, and our customers in the world need to have piston engines operated with kerosene. Yeah? Those airplanes save maybe 25% of fuel compared to an American gasoline engine. This is, of course, it's green. It helps if there is a customer with a high utilization, he can even pay the lease from the fuel saving. But this is just that this is the fuel which is available. It's just the key selling issue. Okay, now back to the presentation. We picked out two topics. One is the electronic assistance systems, which are absolutely important in cars. Yeah? And there is no doubt that the aim is just to reduce the workload from the driver or the pilot. And the other topic that we picked out was electro-hybrid power plants, because this is as well an issue in automotive industry. And finally, for the future things, put those two elements together. The ESAFE program was a funded program with a research program. It's taken more as an example, and now it's easy, we have a movie.
Developing an automatic emergency flight control system, including emergency landing. Diamond Aircraft Industries GmbH. In cooperation with Rheinmetall Airborne Systems, FH Johanneum GmbH, TT Tech, Computer Technik AG, Time-Triggered Technology. To date, no automated landing systems have been available for category CS23 light aircraft, licensed to transport up to 9 passengers. Should the pilot be suddenly unable to fly, then a crash is inevitable. A multinational working group headed by Diamond Aircraft has developed a solution to this problem with ESAFE, an emergency safe return system.
The ESAFE project is designed to allow the pilot or co-pilot to shift the flight controls to automatic at the push of a button. The aircraft then automatically proceeds to the nearest suitable airfield and lands independently.
Flugplatz und landet dort auch automatisch und selbsttätig.
Die Simulation für die Route wird
During the flight, the simulated route is constantly recalculated. After all, the system has to decide which airfield is closest, and this is done continuously in real time.
The system automatically includes the latest weather reports via radar and a satellite downlink in the calculation. If necessary, ESAFE flies around areas of bad weather.
Dieses System besteht aus einer Sensorik und einer... This system consists of sensors and an automatic flight control system. However, the essential factor is the computer software. This software contains a database which is used to calculate the flight route.
ausrechnen und die ganzen Entscheidungen letzten Endes
and takes decisions based on these calculations. We're now working on developing a cost-effective and certifiable solution suitable for serial production.
kostengünstige und zertifizierbare Serienlösung zu entwickeln.
eSafe is a further milestone in the quest to raise safety levels in a time of constantly increasing mobility.
Okay, thank you. We see the assistance systems just a road down. We start with the human pilot, and of course the next is a regular normal autopilot with a limited authority. Then we already have wie sagt man, envelope protection systems, and this is already real in general aviation, and of course eSafe is just the next step to avoid mistakes from pilots and to cover pilots' weaknesses. Yeah? Of course, the next step down the road will be high authority autopilot systems, means autopilots to be able to cover any weather conditions, and just to cover even extreme situations of envelope protection. And the next thing is, of course, automatic landing and takeoff on a regular base, then on eSafe, and very consequently, like on big airplanes, those systems need to have a reliability where the mechanical controls do not contribute much to a higher level of the overall system reliability. And finally, the step will be to autonomous flying with or without pilot finally. Yeah? This is the road that we see. And of course, the speed on this road depends a lot on rulemaking, on required reliability figures. If we start with a human pilot, there is, in general aviation, the pilots have less trained, not professionals very often, and there is somewhere between every 10,000 and every 100,000 flight hours, there is an accident, a catastrophic accident caused by a pilot. And that means if, for example, eSafe means what is the option? 90% certain loss of airplanes means if we are on whatever, one failure every 10,000 hours, this will increase the level of safety dramatically. If we go to the higher steps, if we are, say, 1 million flight hours, a failure of the system still has a dramatic positive impact on safety. Yeah? And means the reliability figures finally will be the key to the speed on this road. Okay, cut. This, I was anyhow too fast. Hybrid electric power plants. The idea of electric flying is not really new. And again, automotive industry is driving the technology. And I like to present you another founded program that we did. It was called HAMAP. This is what the airplane will look like. The project goals were just demonstrating the technology finally, but of course as well other items. One important thing, we have to think about the rules, what might be possible. We will be able at least to present certification procedures or ideas to the authority for this kind of airplanes. You see the consortium. Yeah. You see Airbus, you see Siemens, you see Diamonds, you see some smaller partners. Those are not quite equal partners, but it works. We take just our regular single engine 4-seater as a base for this development, and we modify this airplane. Yeah. The weight is slightly higher. We still take the same diesel engine to generate the power. And one goal was we want to be able to fly at least half an hour pure electric. We made some aerodynamic analysis. The title was multi-engine electric airplane because it's not quite clear how many engines does the airplane have. And we looked at different configurations, including the prop effects and everything. And finally, we picked the first one. We thought about having 6 engines, but it's not so easy to install 6 big propellers on a small wing. And all the hybrid components are located close to the engine, just in order to have low impact on the original airframe. And only the batteries are where originally the passenger seats have been. Yeah, maybe we do a little faster. Yeah, you see the generator is directly plugged to the crankshaft of the diesel, and the engines and the electronic converters are in the engine nacelle, which is on a canard wing configuration. Batteries, Airbus. You know, lithium batteries is one thread in aviation, and Samsung handys is another one. Anyhow, the batteries are contained. We have to contain them. If one cell fails, it's the foam is just going through a chimney-like element. And the design of the battery modules is that if one cell burns, it does not take the others with them. Yeah? That means if we lose one cell, it should not ignite the others. This is just the concept. And the individual model, I think it's 14 modules. One module is just on a low, on a, let's say, acceptable voltage, means you can handle it without exceeding dangerous voltage. But of course, the voltage of the whole system is high, with close to 800 volts, and this is of course a real challenge to deal with those high voltage levels. But our partners insisted in this high voltage levels. Okay, it's arrangement again. Okay, and this is how it was presented on the air show. Already marketing is always required. Okay, and then we are going to the future, and the future finally will be combining both technologies, where maybe finally it will be most likely 8 electric engines driving 4 rotors, and with a power generator somewhere in the rear of the airframe. And of course, an airplane like this has no direct control or anything. Yes? It means it's full fly-by-wire, otherwise it's not possible. And finally, it is not too important whether the pilot is on board giving the commands or where the commands will come. Yeah. Okay, this is already the presentation. I think it's at least a base for discussion. Thank you.
Thank you very much. And now to the next one, the E-Fan.
Thank you, Stefan. Good morning, ladies and gentlemen. Maybe you can give me the control. Pilot control, yes, okay. So my name is Alain Cassier. I'm working in the E-Fan team in Paris, in Airbus, as chief engineer for the E-Fan 2 project. I realize that at Airbus, we are not so well known from what we do in general aviation, rather than what we do in the large transport aircraft category. So what are we doing there? And why are we doing it? That's what I try to explain in this short presentation, and maybe the subject of the discussion later after. Our starting point is the objective which has been set for the transport industry, air transport industry, so-called Flight Path 2050, and our visions for aviation in 2050. Setting goals, today it's a voluntary commitment, but given the pressure that we have on environment issues, it may one day become a mandatory requirement. To cut emissions in 2050 by 50% as compared to what they are in 2005, assuming a traffic growth of 5% per year. So it means, as compared to a typical aircraft, a new aircraft in 2000, 65% less CO2 emission, 90% less NOx emissions, and 65% less noise. Not easy to achieve. And what we see today, what we realize, is that traditional technologies or solutions fall short of meeting this objective. When dealing with CO2 emission alone, for example, we can count on 20 to 25% improvement due to more efficient structure. And when I speak of airframe, I speak of, for sure, lighter airframe, but also some refinement on aerodynamics. Air traffic management improvement may bring another 5 to 10%. New efficient engine, 15 to 20%, and including that, new concept like prof rotor is developed. And alternative fuel, I mean biofuel, subject to if they can be produced, by the way, that's another problem, may bring another 15%. But when you add that up, it's still missing 10 to 25% of the objective. So what do we do? Clearly, we need something else. We need a disruptive technology. And we at Airbus believe that electrical propulsion can be this disruptive technology. Why? Because obviously it's clean. It's clean at least during the flight. And it is allowing new architecture of propulsion systems, of aircraft architecture that may be more efficient. However, there are some prerequisites before we can really apply this to large aircraft. This is to make still progress in the efficiency of generation system, power generation system, or energy storage system. Today, to give you an example, to give you a feeling of what is the gap, there is a factor of 20 in the energy-specific weight of fuel cells, battery cells versus fuel. It means that, for example, 10 kilos of fuels equals 200 kilos of battery cells in terms of energy content. So you see there is still a long way to go. And in fact, this is today limiting the application of battery cell to small aircraft and short-haul transportation, because when you increase the range, you end up spending all your energy carrying the battery. So it means that in practice, there is a limitation of the range and endurance you can achieve, which is quite small. So there is a potential, but today there is still a lot to do in order to achieve the required level of performance of those systems. And even if you extrapolate what is today in the research laboratory, we see easily to improve by a factor of 2, but beyond that, it's still something undefined. We need to also have a high voltage distribution network, so we do not dissipate all the energy in the network. And we need a high efficiency motor and power electronics, but this is less of a problem because today systems are reaching 90% or more, which is, by the way, far better than what you can achieve with a thermal engine. It's a factor of 3 of better efficiency. So this is somewhat counterbalancing the bad performance of battery cells. So when you see that, it's clear that when you start on electrical propulsions, you have to have a long-term goal. It's not something that will end up in a transport aircraft tomorrow morning. And this is exactly what we have. We realize that today, if we want to learn how to use those systems on an aircraft, it can only be on a small aircraft, and this is why we are starting with one-seater, two-seater, short-haul aircraft, small endurance. And after all, this is the way aeronautics started. The first aircraft, they didn't start away with 200-seater, they started with one, a very short endurance, and they progressively developed in 100 years to where we are today. So this is what we believe the path that we have to follow for the introduction of this new technology. So this is why we start with the small aircraft of today, the E-Fan family. And as the technology is improving, we believe that we can apply this to larger aircraft, maybe rotorcraft, and why not transport aircraft, as an hybrid solution in the beginning, and maybe in the end, full electrical power. In doing that, we are facing quite big challenges. One of them is improvement of the electrical systems themselves and power generation, power storage system. But not only, we have also to take care of the inventing the new configurations that those systems are allowing, and therefore maximizing their benefit when applied to aeronautics. And there will be on the way for sure new certification challenges, because we'll end up with a solution nobody has experience with. So now that I explained that we are following a roadmap with several steps, let's speak of the first step, which is the E-Fan family. So family because we have already 3 small aircraft in this category, exemplifying our very pragmatic approach. In fact, we started with a Cricri back in 2009, and it was the first attempt to convince ourselves and convince the public and our internal staff at Airbus that yes, electrical power can be used on aircraft. So to go fast, we took an existing aircraft, a Cricri, and we just changed the thermal engine to electrical engine. That was all we did. But already this allowed us to get acquainted with how to use those electrical systems. The second step was a real demonstrator, and then we took care of designing a complete aircraft, not just taking an existing and modifying it, but optimizing it for electrical propulsion system, and that was the so-called E-Fan 1. It was a demonstrator, so it was certified, no production. However, it was already looking like a real aircraft, and it allowed to demonstrate interesting operational performance. interesting characteristic regarding very low emission and especially very low level of noise. And it was a further step to convince that yes, there is a future in applying electrical power on aircraft. And this demonstrator was equipped with a full flight test instrumentation, and it allows us to acquire a lot of data that now we are using to develop a real program, the so-called E-Fan 2, which I am taking care as a chief engineer. And our objective this time is to go to a full program, going to all the steps of the life cycle, from design to certification, production, and operation, and acquire experience in all those fields. And it will really be a design to market. It's not just, okay, I try to do something to fly around. No, it will have to answer the requirement of the market, and the segment of the market that we have selected is initial training of pilots. So I will give a very short description of the various aircraft. So the first one was the Cricri, and it was a very small aircraft, max takeoff weight 175 kilo. That's almost incredible that you can end up with such a low weight. So we just changed the propulsion system. We went to 4 electrical engines. Why 4? It was a question of cost. We needed 22 kilowatts, and the easiest and fastest way of using COTS was to use 4 engines. Given the max takeoff weight constraint, we could allow only 26 kilos of battery cells, which was allowing something like 20-25 minutes of flight, but enough to demonstrate the capabilities of the aircraft. And in fact, we achieved the same level of performance as the original aircraft with the thermal engines. Okay. So second attempt with this time a full aircraft demonstrator. This is the E-Fan 1. This is a full new design. Was intended to demonstrate operational capabilities of electrical propulsion. As you can see, we have 2 fans. Why a fan? Because we wanted the aircraft to be very efficient in terms of noise limitation. So fan is good for that. Why 2? It was also a question of integration of the aircraft. It's easier to integrate 2 fans than 1. And a question of costs. There was a lot of choices in the 30 kilowatts category, less in the 60 kilowatt category, so that led to this choice. And on the aircraft, we had 170 kilos of battery, which is giving an endurance about 1 hour. You know that this aircraft crossed the channel last year successfully. That was a culmination of the career of this aircraft. Anyway, as I said, it allowed us to acquire a lot of data. And those data are now used for the design of the E-Fan 2, which is a true production program. Rather than going through the characteristics which are on this chart, which are quite preliminary because we are still optimizing the aircraft, we are still in the design phase. I will explain what we are looking for with the aircraft. First of all, I have to say that we are not alone, that we are working with Daher Sokata. They are responsible for the design of the airframe itself, and we at Airbus, as the overall contractor and in charge of the electrical propulsion units. This is where we want to acquire really experience. And our target is really to answer to a market need. So we do a design to market. We design the aircraft specifically for its role of initial training mission. And the mission that we are targeting is 1 hour plus 30 minutes reserve. It has to be attractive, so good performance, and it has to be environmental friendly. It means that it needs to have no emission, and especially very low noise, and allowing to help the training schools and the aero club to face already the difficulties with their neighbor and the complaints they have on noise, and forecasted limitation on use of aircraft in close to cities, and especially the weekend. A secondary target, which is very important, is to achieve business and operational objective. We really want this aircraft to, it's a real program which is ending with a production and operation, and it has to stand by itself, it has to be profitable. And it has to bring to the end user a significant cost reduction with respect to the current aircraft. Our target is 20% reduction of cost of ownership versus the existing aircraft. And this is achieved not only by the reduction of fuel costs, electricity is cheaper than fuel, but also by a reduction of the maintenance cost. We are taking care of delivering a product that will deliver a complete service. That means that we are also taking care of developing the ground tools and means which are necessary to support the aircraft, like the recharging session. Our target is to have a turnaround time between missions of 1 hour, so we need to recharge the batteries in 1 hour, which is not so easy. And all the means that you need to prepare the training missions and to help the instructor training the pilot. So it will not be only an aircraft, but it will be an aircraft and ground support equipment in order to optimize the performance of the aircraft in the training mission. We are taking care also of the production activities. We have created a dedicated company to take care of the aircraft, which is fully owned by Airbus. Its name is Voltaire. Voltaire will have the final assembly line and will be responsible for the commercialization and the support of the aircraft in operation. And in association with that, we are developing the supply chain necessary to support this production, either for airframe components or propulsion system, electrical propulsion system component. I put it at the end, but it's obviously one of the main targets of this program, which is to prepare the future of Airbus. As I was explaining, we see that we will need this technology, so we want to get acquainted with it. And when we say this, we fully realize that all the solutions that will be developed on the E-Fan will not be scaled up so easily to larger aircraft. So our purpose is not to design solutions that we can reuse one-to-one on our future aircraft, but rather to gain experience on how to use, how to integrate an electrical propulsion system in an aircraft and make it efficient, to train our people and develop competencies. If you go to this technology, we need new engineers which are trained in using those technology. And when with a program which is going to operation, not only we will gain design experience, but we'll gain also operational experience. And when you introduce a technology like this in the air transportation, it's very important. You cannot just send the aircraft in operation and say, okay, now you have it, use it. You really need to make sure that it will be really operational. Obviously, we are not doing only that to prepare ourselves, and there are other programs like developing distribution system, electrical distribution system for high power system, and we are working also on how to develop hybrid systems on larger aircraft, but okay, that was not the purpose of this presentation. Thank you for your attention.
Thank you very much. I directly hand over to Linda.
Thank you. Good morning. My name is Linda Brussard. I'm one of the electrical systems experts working at EASA in the certification directorate. So we have seen a few examples, which are mainly also on electrical propulsion and combining road and air. But we see also some new technologies emerging in GA. We all know the famous aircraft that just flew around the world on solar panels. These are really examples. I mean, it's not that we have already applicants that are using these technologies, but we see it in research and on aircrafts used. So I think the solar panel was in the end successful, so they finished their journey around the world. Of course, we see electric motors. I think there's a lot of emphasis right now on electrical engines, electrical propulsion, either in combination with conventional combustion technologies or completely full electrical. We also see the development of fuel cells. Of course, the technology of fuel cells, not really new. If you ask NASA, they say, oh yeah, it's really old. We use it already for a very long time. But for us, it's quite new, and I think a quite promising technology, a quite promising development next to the batteries. Another thing is the on-demand mobility, so to serve really the customer on where to go, how to go there, and how to get there. We see more and more also emphasis on this, I think also in this panel. And also the new propulsion can lead to new things in aerodynamics to better serve the aerodynamics, to make the aircraft more efficient by using some features. So what do we already have as certified under EASA? Well, so far we have certified electrical engines on some gliders. So I put here some examples together. So the first one on the top one is a glider where you have the engine on like a big beam that pops out when you need it. The lower one is also quite a nice example where you have the propeller actually in the nose. When you are just gliding, the blades of the propeller are just nicely folded backwards, so you have a nice aerodynamic plane. And when you need some help of the engine, it folds out and just by starting to rotate actually, which is also a very nice concept. So these are already certified under EASA, so it's just also a nice example to make clear, yes, we can also support electrical engines. And then of course we have also some future projects. What already arrived is the E-Fan, which was just presented to you in much more details. Airbus Voltaire already applied for the certification and early 2015. And so we are already involved in that, and it's for us also a very interesting concept, technically speaking, of course, and also to see how we can support this kind of aircraft to get its certification. Of course, we also speak with other manufacturers, and what we see on the radar is hybrid airplanes combining different ways of propulsion, some electrical aircraft, ODM, and much more is coming, I hope at least, in the near future. I just take a moment to let you be scared with this nice slide. Actually, when new technologies emerge, we look at our requirements and then we see, oh shit, we didn't think of that before. So we have to do something. And actually, internally, we started up a project, if I may say so, to see how we can incorporate electrical propulsion in our current regulations. So this is a quite complex picture. In the middle you see the electric propulsion, which is the Of course, the reason for this mind map, it's actually a mind map. Maybe some of you are familiar with the techniques. And then the colored bubbles around it represent the different aspects that you will have to look into if you start to make some real making or make things possible. So first we start with the gray areas, which is research. So we have also to support research. We have to be involved in that to see what's coming, what are the technologies that are really used, what's thought of, what can we expect. So the green next to it is indeed the technology. So what is the industry thinking about? What kind of propellers, how many, what kind of energy carriers they want to have. That's all about that. Then of course there's a general philosophy needed. What do we think about? What's the customer wants? What do our manufacturer need? What does the pilot need? Or maybe the pilot is not inside the aircraft, as was also mentioned earlier. We have to think really out of the box here, I think. Then we also need the input, of course, of all stakeholders. But who are all those stakeholders? Obviously, it's the people here in the panel and you in the audience. It are the future users. It also are the people outside the airport. What do they want? What do they need? So we have to get also their feedback. Then I have to look a little bit closer. The dark blue one, yes, sorry. It's too much to learn by heart. The regulations, so which regulations will be affected? It's not only the technical regulations like the CS23 or CS25, but we also have to think about licensing, operations, maintenance. There's a lot that comes together. So I don't know what kind of color it is, the light bluish one. It really collected all the nasty CSs that you're all too familiar with, I guess, and the ops rules, which is for other people, maintenance and everything. Then what we are also using, of course, is standards. So we know the SAE standards, the EuroCase standards, ASTM standards. I think there's already quite a lot out there, actually, for if you are talking about electrical propulsion. Of course, the automotive industry has already quite gained some experience with electrical engines, with hybrid engines, with batteries. I think we should also not forget to look at them. And also there are standards continuously developed regarding electrical propulsion. And then we have again a green one, so the certification process. It's also something we are looking into right now. You probably all know that CS23 is being revised. Also Part 21 will be continuously revised to make things easier. So to support in the process also the new technologies that are emerging, not only electrical propulsion, of course, but also other technologies where we can and where we can foresee them coming. And then there's training as well, because we need to train people. That's the last purple one. So I hope I guided you a little bit through this very complex slide, which actually is quite complete in what we need to support the electrical engine from our side, from the authority side. The title is Flexibility and Certification. I'm not sure if you've seen it. I'm not sure if this really is flexible, but it's just an overview of, we start with the basic regulation, which puts EASA into place by the Commission. Then we have the implementing rules like Part 21. And then under that we have the non-binding rules like the AMC to Part 21, CSs and all other ones. So I will go quickly through this, it's too boring anyway. So we go to the real flexibility in certification. So what tools do we have today to make things work for you? Of course, special conditions. I know it always sounds a bit scary, but it helps us to really set out a set of rules that really support your needs. So for electrical engines, we have one special condition, which is changing, for instance, parts of CSE into things that we need really for electrical engines. What we also can do is issue what's called restricted type certification. It's a bit easier to get that one and to get your aircraft out there and fly and get experience and knowledge about the new technologies and how they behave on the aircraft. Then there's also the option outside EASA, which maybe is forgotten sometimes, which is called still Annex 2. It's microlight, experimental aircraft, research aircraft, and these Annex 2 approvals are handed out by your own local authority, which makes things easier. They are more local to you than us, so it should also be more quicker for you. Then we also know that CS23 is being revised at the moment. The NPA was already mentioned. It has been published earlier this year. We received a lot of comments. So we are working hard on it internally to get all those comments answered and changed the NPA where needed. It's also a quite challenging objective that we have there, because we do not want to say you have to design like this, you have to, we don't want to be prescriptive anymore, but we want to give safety objectives. And also, in order to give safety objectives, we also enable again the new technologies. And when you're perspective, it's a difficult word, sorry, perspective, you stay with the things that you know nowadays, and you don't enable the emergence of new technologies. I go a bit fast because I also want to give the floor to you with questions. So actually, what is this new concept? This is just an example. If you see above, you have an extract of the current CS23 on 619, and the yellow part is now transformed into what's below. So it's really making CS23 much shorter, and I think that's very good. So it gives you really the high-level objectives, and then of course we refer to standards that we work together with industry at the moment in the ASTM F44, and these are means of compliance. So there's a lot of information there, you can use it, and of course there's also, as usual with the AMC material, you can also propose your own means of compliance to us. It makes things more flexible, really. Come on. Next to that, we also are looking into part 21 with a proportionality. What does that mean? It's again to introduce flexibility at the smaller end of GA, where we want to really look into what's the risk of the aircraft and how can we, of course, achieve still an initial safety level, but also to still help you to get your product out there without being bothered too much and still be safe. So the scope is to have within a certain boundary, get you gliders, LSA, small CS23 aircraft certified together with qualified entities and the national authorities, which are again closer to you, which makes the communication easier, and with them get your product designed, produced, and certified. So again, we are trying to enable everything you need to make new technologies easier to get introduced on the CS23 aircraft. So I will give back the control to Stefan, and you please feel free to ask questions.
Yeah, thanks everybody. Can we have a look on the questions that we have in the system? I would like to start with a question with, remember the keynote. We have seen a lot on what is done and how it is done or how it should be done. And one question for me would be why. But maybe you can have also a look on the question. Maybe question 2 and 3 seems to be for AeroMobil and could be related. So please, why do you invest all this time, money, effort in implementing these technologies, talking to 1 or even 2 authorities?
I think for 2 reasons. All the changes in our society has came from a dream. At the beginning, it's a dream, it's passion. In case of AeroMobil, it started with a dream. But this dream can become a product, and this can change the society. For example, with AeroMobil, we will propose a new transportation mean. We imagine some new infrastructure. For example, on the motorway, we imagine there's a tank station, and there is a 400 meters field, and then you drive out of the motorway, you take off, and you fly home, or you fly to your destination. Then all this start for the dream, and then the dream becomes a change and an improvement of the society.
Same for you, but maybe you can also. There's one question where really the democratic seems to want some more.
Okay, I agree. It's a dream on one side, but of course, this assistance systems is a clear goal. Contribution to safety. The complexity gets higher on new airplanes, and we have to bring the workload for this non-professional pilots down. This is quite clear.
There's one question related to this safety. When you fly more or less automatic to the nearest airfield, how do you ensure the safety for this for this phase of the flight?
Okay, looking at the question, of course, for the first step, we just switch the transponder to the emergency code, means it's a declared emergency. Of course, with future technology, we think it might be possible to establish a communication between air traffic control and persons on board. But the first step is just switching this transponder, that's the idea. But anyhow, in all the new technologies, the operational issue is always much more difficult to handle than the technical issue.
Maybe related to this, there's especially one question. What are the main challenges on these regulatory sides, on these aspects? In which areas do you see the most problems? Is it certification, operation, what else, ATM licensing?
I have to say that I'm more acquainted with the CS25 than the CS-LSA first, due to my background. So my starting point was to be too much impressed with the certification process, but maybe I'm wrong. Yes, there are specific challenges that we are facing, and they are due to, let's say, the scale of the project and the low costs that we are creating. It's clear that we have a very small budget. The aircraft has to be cheap. And therefore, we cannot afford expensive solutions. So it's bringing to a very technical challenge to us. That means we have to rethink simple. The complex solutions are not allowed. We need to think especially with regard to systems and how to ensure the safety without very costly redundancies that we use on CS-25 aircraft. The second point is how to reuse COTS, and especially automobile COTS that was mentioned by Martin. And we are facing the same issue, and therefore we are very much interested in the willingness of EASA to consider automotive qualification as an acceptable means of compliance for aircraft certification. We are really relying on this. And in general, any other industrial standard that is providing a reasonable or equivalent safety level, we would like to use it if it's possible, yes. That's the main issues.
Yeah, on this latest point, I definitely can confirm that this is the intention of EASA to enable the use of standards as a means of compliance. That was one of the commitments from the Rome Safety Conference, and that's the main objective of the new CS23, which to reduce the requirements. The regulatory text is cut down to nearly 10%, and then make use of standards that are available. And there we also have to talk about automotive standards, alternative standards, and how to integrate them into the system in an efficient way. When looking on the second question here, I see one element for EASA is it's about these flying car. AeroMobil, is EASA planning to allowing these vehicles to land anywhere? That's really a very good question, and we have seen also the other project, vertical takeoff operation in cities, and it will be a challenge. And we have seen the mind map on electric propulsion. If we add the new elements on integration into ATM on the licensing aspects, if this takeoff is performed more or less automatic, we end up with a much more complex mind map, and there's a lot of work to do. So, but with this in mind, so I think first to the control on these small aerodromes, or how we would define these places for takeoff and landing, is under national control. So we are not involved directly, but of course this will affect dramatically the aviation system. And honestly, I see a lot of synergies there with the ongoing rule development on unmanned aircraft. But the question 2 and 3 are mainly for AeroMobil on the market, on the intention, and on the constraints you have.
Yeah, first on the runway, it's clear that today the flying car has to land on an airfield. In many countries, we have some laws, some possibilities to create temporary airfield, private airfields, and those are solutions. And we also imagine at AeroMobil some runways parallel to the highways, the car highways. We really think that it's the future, and as any new idea, we need time to implement it, but perhaps we'll find a country, perhaps here, to test that solution, and that's the idea. For the market, the flying car is a new concept. In AeroMobil, we imagine that the customer for the flying car, it's everybody, the whole of you. Of course, the starting point should be rich people. Is that the good word? Because the first products will be a bit expensive, but then if we are able, if it's a success, if we're able to modify the infrastructure, it could be everybody.
Okay, thanks.
Sorry, I have a question on this topic. When you say that the user can be anybody, I would like to challenge this a little bit, because not everybody is a pilot. So doesn't that militate for a fully automatic flight?
Yes, thank you for the question, Alain. In the AeroMobil plan, in the future, we should have an autonomous vehicle. and then even someone who is not a pilot will be able to use our vehicle.
Okay, thank you. If you would allow us, I think we would like to use some minutes of your coffee break. I see a lot of technical questions, and I would propose that you approach the panelists during the coffee break, that we hope to leave some minutes over. But I would also like to get some questions from the audience, from the floor, that do not use a smartphone during the discussion. So, do you have any questions?
Marcus Warners, Swiss Civil Aviation Authority, FOCA. Just a question for you, Linda, for you, Stefan, as this OEM on-demand mobility is something which we will have in the future, and which is more related to operation and integration in fields which are not coming from authority and which are more tied down to the local national authorities. How EASA is prepared for that to shift more and more responsibilities to the national, not only civil aviation authorities, to all the national authorities, so they can work together on their home place to integrate these vehicles into the normal system.
Thanks, Marcus. It's definitely an interesting question. For me, I see also in that aspect a lot of synergy with the ongoing development on unmanned aircraft, where we of course have to use proximity as one of the factors to determine where decisions are taking on the regulatory aspect, on the authorization of a flight. But of course the overall concepts that are really coming, Airbus made just a press release yesterday or the day before on a similar concept. They will come, and they affect also the overall system, that it's not just limited to one member state or one local area. It's affecting the ATM system, it's affecting the licensing system, it's somehow affecting the legal system, and there we have to do a lot of work on European level to make it possible then on the local level. Yep.
Of course, the other side.
Thank you. I'm Xavier Barral from the French Federation of Aeronautic. We're dealing with 600 aero clubs in France, and it's a question to the E-Fan and my colleague from Airbus. Why you don't afford the VLA certification? Because we need your product for VFR night flights.
Well, it's really a first product with limited performance. Given the current characteristics of the battery cells, we are limited to 1 hour operation. I don't think that with that you can envision navigation flights really, or very small ones. And in that sense, for us, it was enough to stay VFR day for this type of mission. But obviously, there is no problem to extend the mission of the aircraft to VFR night, which is allowed in the US, not in Europe, if I know well. However, to go to IFR, it's something which is today beyond the scope of the program. You don't agree?
But also there's some additional comment. We get some flexibility with the new CS23, where VLA will be integrated. So we have the first entry level in CS23 are aircraft that are today VLA. And the idea is to have modules that add some complexity in the certification requirements when you add certain operation or functions on the aircraft. So we will have a lot of more flexibility to allow, for example, night operation of VLA, which we do already today using special conditions. One last question one last question.
Hello, Christophe Larat, USPNT, Union Syndicale Personnel Navigant Technique. So it's a French airline pilot union federation. I got a question for ESAFE. I agree about that private pilot knowledge, skills and level maybe can be replaced by robot. We heard about that yesterday. But I don't see how you tackle about adverse weather conditions like icing condition or thunderstorms, because nowadays it's still the pilot who can be really active about that.
Yes, of course, you are absolutely right, but we regard ESAFE just as a first step to higher authority autopilots and assistance systems on all levels. It's quite clear it's in difficult weather situations, each system has a limit, and of course we are not that far that our ESAFE can handle even any wind conditions on the ground. Yeah? Not for real safe landing, but we can bring the airplane down to the ground. But anyhow, it's just a first step.
Okay, then thanks everybody here on the panel. Thanks everybody for listening. I assume we come back at 11. Okay, coffee break until 11 o'clock. And we are all available here. If you have technical questions on details, please approach us. Thanks.